strings are also sort of arrays.
What do you say, sort of?
Because strings are read-only. I cannot do this, I think. Yeah. So strings you cannot. Strings are what you call immutable. So if I have a string, then it's always going to be the same. If I'm going to append something to it, this is going to create a new string in memory. So now we have the string foobar and we have the string. What?
Yeah, because you added.
Oh yeah, sorry. So now we have the string foobar and we have the string foobar blah, which are two different strings in memory. And you can't modify strings like you modify arrays. You can only take parts of them or combine them. So in Go, if you do something like this, if I do this, that's going to work. This is going to be really inefficient because first it's going to allocate the string foobar, then it's going to allocate a string foobar blah, then the next time it's going to allocate a new string foobar blah blah, and so forth. So that's why if you want to do something like this, you usually do make an array of strings. So here again we use a slice, so I have a slice or an array of strings. I'm going to append blah to it all the time, and then at the end I'm going to use the built-in function in the strings package, concatenate, x. So, sorry, var x is an array of. No, I need to. Yeah, sorry, I have to say a new keyword. Okay, this. Yeah, I'll explain that now. Why not?
Concat something with something.
Yeah, and
something.
what I want to join them with, like the separators, like comma, whatever. If I do comma, that's not if I do empty string, and it's. So what this is going to do, this is going to be more efficient. So I'll explain the make keyword after this. I have a slice of strings. I append blah to it each time. Since blah is immutable, it can just use one instance of the blah string. It doesn't have to create a new blah string all the time. It just has one blah string that it constantly appends here. Because strings cannot be modified, so it can just reuse the same blah. And then strings.join is like a sort of built-in function which does that plus is all the time much more efficient. Strings.join is gonna look at like, oh, how much memory do I need for the end of for the complete string? It allocates the complete memory for the string and then fills it in with all the parts. So this is going to be a lot more memory efficient. Make, if you create a new, this is actually exactly the same. I can say I want an array of strings that is empty. It's going to be exactly the same. But Go also has the make keyword, and make you have extra arguments. One is how many initial values should be in it. So if I do 10 here, okay, that's going to be a bit weird, but now x is already going to have 10 empty strings in it, but because we can't see empty strings, I don't know how to show this. Another thing that it has, which is another minor optimization again, is a capacity. So you can say here, I want to start with 0 elements. I already know I'm going to put 1,000 elements in it, so I just start with a capacity of 1,000. So the slice will still have 0 elements in it, but it starts with enough space for 1,000 elements. So if I do it like this, now x is going to be 0 elements. Show capacity of x. So now again, x is going to start with a capacity of 0. I append one element to it, so it's gonna have a capacity of 1. I append another element to it, gonna have a capacity of 2. And you see it like grows exponentially. But and every time you see that it jumps in size, it has to reallocate the array in the back end, copy it over, so you have more memory. I can say, I know already I'm gonna put 1000 in, so I just start with a capacity of 1000, I run this, it's gonna always say 1000 all the way to the end.
It may not look that interesting for now, but when it comes to performance, it actually makes quite a fair bit of difference when you run those micro benchmarks. If you pre-allocate and you know how much memory it's going to use, there's going to be less impact on the memory management. And if you guys heard about the garbage collection in Go, etc., is that if you give these extra hints to that, it's a lot less work that the garbage collection, the garbage collector has to work. So for longer running processes, this is actually a huge performance optimization. Anyway.
So far, string sounds like strings in C.
Yeah, but in C you can, in string it's just a byte array, so you can change stuff. And in Go, like you cannot change the contents of a string. If you want to change the contents of a string, you have to build a new string with all the parts you want to have it consist of.
And you can easily have a string with a 0 terminated string. I mean, you don't have to have a 0 terminated string. Like strings in C, you have to have one extra character. Yeah. Anyway.
Okay,
Behavior
next
is
thing.
more or less.
Structs.
Similar, yeah, very, very similar.
In Go, you don't have classes, instead you have structs. Don't ask me why. The people with from C are probably familiar with structs, but what in C is called a struct is actually, what in Go is called a struct is what you would call a class in C. So, okay. Anyway,
C++ structs are the same as class.
Define structs with a type
Anyway.
keyword, so I say type A is
Yeah,
a
it
struct.
just means all members are public.
And then the members, so I can say like Y.
You can use struct as you used to be able to.
Then
Struct
I
is
can
just a
say
class
like X is
all the
an
members are
instance
public.
of that struct, and I can like, you have other
Anyway,
languages you can
that's
just assign
long
something
time
to
ago.
it.
I may be wrong.
Go doesn't have like this syntax, which a lot of other languages have. It's always a point, doesn't matter if X is a pointer or an instance or whatever. So if I run this,
String, spanning line 9.
Yeah.
so this is gonna, okay, I can do actually in Go, which is even nicer, I can do %, hash v, which is gonna print, it's a struct of main.a with x is 2 and y is empty. So this is actually quite useful for debugging.
So it should
It does
Yeah,
to me.
it shows the precise type.
I didn't know that.
You don't use this to
I didn't know
debug?
that.
Then what do you use to debug?
Just print
Um,
X.
Structs can, so if you want to have groups
It's not formatted
stuff
so nicely.
together, you can structs can also have functions, but I don't declare the function in here. Instead, I use this. So I have a function foo, for example, and then I say a.x is 4.
X dot full. Follow-up question about the arrays general real quick. Is it possible for you to have arrays with multiple types of values?
No, an array only has one.
Well, you can have array of interface empty.
Yeah, but let's
it's,
not get into that.
Okay.
Let's say no. So structures can have functions attached to it, which you write like this. So it's a function, but where if we have global functions, we just have like this, like the function foo. If this function acts on a struct, we just name the struct first. So this is the name. I name a variable a, which is type a. Okay, that's a bit unclear. X, let's do x. Then in here I can use x. Maybe this is a better example. X dot x. And now it's gonna get. So if I execute this, no,
X dot full.
sorry, So what this is gonna do, it makes x into an instance of that struct called A. I assign 2 to the variable x inside that struct, and I do call the method foo on it. So now this x is gonna be the same as this x. I can also call this y maybe for clarity. And we print like that. What I just had, now pointers are
Why
coming
do
in
you
handy.
why do you use set?
Huh?
Do you set on these?
Because Python set
Yeah.
That's
Yeah.
not
You can, sometimes I do that, like say I do write self here as variable name. It's sometimes a bit more clear for people who are used to that. In Go, usually people don't write self or this here, but self and this are not reserved keywords in Go, so you can write them. You can use them. And if I'm going to do this, y.x is 4. What does everyone think now is going to happen? So I assign x dot, what let's not call this x.
2.
Okay, I assign z dot x to
Variable
2,
naming.
then I call the function foo, which in theory sets it to 4, and then I print x. What's that gonna print? It's gonna print 2.
Yay.
Why? Because here I call foo on z, but here it's a value, so it's gonna make a copy of z. So y is not gonna be exactly z, no, y is gonna be a copy of z.
Which is not
So if I want to modify this set, now is where we're gonna see pointers. So I'm gonna say this is a pointer to y is a pointer to x. So now foo is not a method on the value of the struct, but it's a method on the pointer to the struct. All the other things I don't have to change, like in C you would have to write this instead because it's a pointer. In Go it's all automatic, so I can just do this. So what it's now gonna do is it's gonna call foo, but instead of passing z as a value to foo,
Water leak.
Whose bag is that?
oh,
Better move the bag away.
okay.
Do we have
I
a
don't
cup?
think this
to-
aircon is used much.
Can we just get a cup and
So-
put it there?
Instead now, it's, oh yeah.
Yeah.
Put that as it.
At least the cup is not so bad.
Oops.
Noisy.
Turn it off.
So
It's
now
gonna be better
instead
then.
it's,
Unfortunately.
this y is a pointer to this, so now it's gonna print 4.
Put some paper in.
So in this case, the pointers, you see that the pointers are gonna be useful.
But it's still not exactly classes.
No, it's still not exactly classes. So I can also not say here, in the definition of A, I cannot say what kind of stuff it's gonna have or anything. Like later I assign this and I can do more methods and stuff. What did I have next? Okay, interfaces.
Yep.
In Go, you also, let's keep this code. In Go, you can also have interface. So I can say type B is an interface. With an interface, I can say, I cannot say what kind of variables it needs to have, but I can say this interface says it needs to have a method called foo. What I can have now, I can say for y, I want to be of interface foo. I can say y is x, and then I can go y goes foo. Print this should know it's not gonna work. Ah, sorry.
The last line print.
Cannot use a what?
Sorry, it needs to be like this. And then this is so an interface is what in many other languages is called interface as well. Is just saying I have a type, I don't care about its implementation of the type, like how the functions, what the functions do, whatever. No, I just have a type B that needs to have a function foo. So if I make a variable here, I have variable y, which is of the type of that interface. So the only thing I know now about y is that whatever I put in y, it needs to have a function foo that can be called. So I can assign n. Yeah, okay, let's change this a bit. This is maybe a bit clearer, so we don't have any pointer stuff going on. So the only thing about y that I know is that it's needs a type that has a function foo. Well, I assign it to x, and x is of type A, which happens to have a function foo. So this is valid, and I know that y has a function foo, so I can call it. If I would say this function is not called foo, but it's called foo bar, and I try to compile this, it's gonna say here on line 25, it's gonna say I'm trying to use x, which is type A, as a type B, which is an interface which expects to have a method foo, but it doesn't have, so A does not implement B. Same as if I would write bar here, I expect to have a function called foo bar. It's gonna say exactly the same.
So
Maybe you just put some tissue paper
Yeah,
inside
put
the cup.
paper.
Tissue.
Is there any tissue?
I don't know.
It's better just get a
We should have
Try
some
to
paper
find
on that.
something, just get a piece of paper from that stack there.
Is the
Oh,
type
yeah.
key open?
I'm not
Yeah,
sure
there's
there's
a
any
kitchen
connection.
behind here, otherwise.
Other.
Okay.
That's already, okay. So, I have type A now, which implements B because it also has a foo method, but I can also make a type C, which is struct, doesn't have anything, which also is going to implement the same. So now I have a new type, C, which also has a function foo on it, but C is completely different, but still, if I'm gonna make this of type C instead, then it's still gonna work, because this is still just something, I want to have something there which has the method foo on it. Y is x, well x is now not A anymore, but it's C, but C still has foo, so it's still gonna run, and now it's gonna print blah blah, so now it's gonna call foo of the C instead of A.
Can I ask? Can I require the full function to return integer in the interface?
Yeah, I can say like here it needs to return an integer, and now it's gonna say like, wait a minute, I cannot assign this here, because C actually has a method foo, but B wants to have a method foo which returns an integer, and it's not the same.
Then what about if I want to have implement an initiator, a constructor?
Yeah, I can say like, well,
You don't use interface to do the sort of things, exactly the
No.
things you do in
No,
your interface.
Java can do that, but
Exactly.
constructors you usually don't do. Usually, if you have a type A, you also provide a method like a new A, for example, which returns an A, and then you.
In short, we
return
use
A,
factory
and then maybe
methods.
set some
Yeah.
default values or something.
Ah.
So
That's-
struct doesn't have constructor.
Struct doesn't have a constructor, no. It's usually the everyone does it like this. You provide a function to create a new thing.
So it's not part of the type, it's not part of the struct.
No, no.
it's not exactly classes.
Not
Yeah.
a class.
You got a question?
So when you do y equals x, that's a shallow copy or is it a deep copy?
Actually, interfaces are all pointers.
So shallow.
Shallow.
Shallow
Yeah.
copy.
Well, not copy at all.
It's not copy,
gonna
just
say
pointers,
like,
yep.
because I say var y is of type B, that actually means like y is always a pointer to something of type B. So that's why here when I say y is x, it's gonna say like y is a copy, is a pointer to x basically, and that's yeah.
Yeah.
So is it only like,
And-
is it like only copy, refer by value if it's only integer and string? Then every time else is refer by pointer.
No. I can also. How can I show it? Yeah, that was this example. So if I do here y dot x is 4, and I do here x dot foo, and I print x dot x. That's I can say like x starts as 2. What? So here I have a, which the struct a, and I initialize x to true. I call x dot foo, but because it's not a call by pointer, it's by value. It's this assignment of 4 is basically gonna do nothing, and I still print 2. And if I do this, maybe another x dot b is equal to x, and then I do x dot b dot x is 4. So now I have x, x dot x starts as 2, I assign b x to b, then b dot x I make 4, is still gonna print 2, because this actually says like
Copy.
make b a copy of x. If I say make b a pointer to x, then it's gonna print 4 instead. Because now I say b needs to be, instead of a copy, it is a pointer to x, and I want to change b dot x, so it's gonna change dot x of what b points to, which is x. So structs are also, everything can be passed by boundary. What I want to show with the interface stuff, so interfaces are, well, implicit you call it. So the compiler automatically sees like, oh, I have a struct C here, C has a method foo, like, oh, then C implements interface B. Like you don't have to say, I can actually say like, oh, C needs to implement B, that will also be fine. Oh.
Oops.
I can say C needs to implement B, that's fine. If I then comment this, it's probably gonna complain even earlier.
Click imports.
See, sometimes it's annoying.
Yeah. Yeah, that works.
No, actually that's not
Oops.
even gonna complain. I thought it would complain, so this actually does nothing. It's just I can, well, basically nothing.
Okay,
That's not
how
good.
do we define the implementation of interface and variables in the struct at the same time? So C
Well, if I have an
implement
interface, I cannot say B needs to have a variable
No.
x of type in. That's impossible.
how about C implements B and C have variable
Okay.
A and
That is also something I'll get to next. So
Okay.
that actually has nothing to do with interfaces. So I'll remove that interface stuff. So interfaces are just like, you can say a specific type needs to have specific functions, and then everything that has that function automatically implements that interface. Maybe this is a good thing to show. So in Go you have a lot of predefined packages and stuff, and for example you have a predefined package IO in which you have an interface type called reader, and it has a method read which as argument has a byte slice and returns the number of bytes it read and an error. And then if you have for example the OS package, so the OS package has file, type file, and type file actually has a function called read, which is exactly the same. So the type file actually implements the reader interface. And you have a lot of other packages such as IOUtil, for example, which has a read all, which expects, like, as argument to read all, it expects an IO reader. So because file implements the IO reader interface, here IO, this is the IO package, not reader, because it a file implements that interface, I can pass a file to this read all function. And so there's reader is one of the really basic types in Go, interfaces in Go, that a lot of functions expect something that implements this interface. Same for writer, which has a function that always writes. Same for stuff like read closer, which also implements a close method. So for example, sockets, files, some byte stream stuff, some whatever, a lot of stuff implements one of these interfaces, so you know, like, oh, that's easy to use. Inheritance is done in a different way. I can have, say, if I have type C, which is a struct, I can say this inherits from A. And I can say it has also another string or whatever, C. So now we have type C, which actually also contains everything of type A. So let's call this bar. So now I can say C.
So C kind of inherits
And
A.
now I have x dot, so C has the variable Z, so of course I can do this. But C also has everything from A, so I can also
X and
assign dot x, so
Yep.
I can also do this. Now if I run, still gonna print 2. So now I do x dot foo. Well, C doesn't implement foo anymore because I renamed that, but A still implements foo, so it's just gonna call this one because C inherits everything from A.
And can I override?
How do you mean?
If both defined.
That means I
Yeah, okay, if this one also
Is
has
foo,
foo, then it's gonna take the one from C, because C is the higher type, or the type that wraps A. It's gonna print this foo. But I think I can call this as well. Yeah, so I can actually say, like, no, I don't want to call foo from C, I want to call foo from A inside there. So I can still say I want to call like a function of a parent. So I can also do this. So if you would have something like a constructor, like this would be like super dot whatever. So this is still gonna print 2. That was interfaces, then we go to maps. One thing that's always missing in language like C is like an easy map or hash table, or what other dictionary is sometimes called. In Python it's a dictionary, and I don't know, hash is usually the way it's
Oh.
implemented. Okay, so I can say I want a map, I want as key, I want strings, for example, and as value integers, and I'm gonna say I want foo to and var 4, for example. Now if I do this, so now I have a map with its key, and string is a key, value is integer. I can say a blah is 12, whatever. So now blah is 12. I can also I can print only one value out of it, so I only want to take foo out of it. It's gonna be 2. So it's basically a lookup table, hash table, whatever you want to call it. It's built in, so the map keyword. And here it becomes, if you would have something like this in C, it would probably be like an integer inside a string map or something, I don't know. You can also have in Go, because it's the other way around, you can have stuff like this. I want to have a map of strings as key, and as value I want to have another map of strings, and then I want to have an integer. And now I'm gonna say foo is going to be another map of string to int.
Yep.
Where I do bar is 4. now this is gonna be invalid, gonna cause an error, because it's gonna say 12 is not of type map string int. Let's remove that. So now if I take foo out, I get like a map of strings to integers, so I can nest that. So now this is gonna be a map of string to int. Or I can say I want to have it be a list of integers, and then we have a list of integers. So now, what? Oh, sorry, here also the list of integers. So now, if I take a foo, so in other languages, in Python you could probably like this, and in JavaScript, in Go you really have to write it like this. So now we have a map with strings as key and then as value, another map with strings as key and then as value, and a list of integers. So you can make the types as complex as you want. I can also say here a list of maps of whatever. So now it's going to be
XML.
it's going to be something like this. And I don't formats. No. Sorry. Oh. So now it's like foo is a map of a list of this is not even correct, I think, is it? No. This is going to be a list here, sorry.
You need a list
Yeah, so
inside.
you can make types as complex as you want.
Right, it should make creating JSON interesting. Yeah,
Yeah.
which is why they got a separate module.
I
for
guess
it.
JSON is something you can explain.
Just use interfaces. Easy. Empty interfaces.
No, no, no. I can give some quick JSON example.
Yep.
Just to show how it works.
Uh,
Encoding JSON.
Encoding is easy. Decoding is a different story. Yeah.
If I have this whole thing, I can encode it to JSON. So I want to have
JSON Marshall.
so I'm not going to do anything with error anyway. But just for clarity, I will write this. Usually when I'm writing quick code, I do this. By the way, panic is, well, I'll show later. And otherwise,
Throw in exception.
okay.
String.
JSON works on not on, it doesn't return a string, instead it returns an array of bytes. I don't know why they choose it like that, but an array of bytes I can cast to a string, so this is the JSON according to that. And I can also do, if I have some JSON. By the way, that I didn't explain, in Go you have two different types of strings. You have this type of string and you have this type of string. If I do a new line in here, and I do a new line in here, remove this for now. Sorry, yeah, like that.
No, you're closing.
Yep.
It's backslash and
Single quote.
double quotes.
26, line 26. Yep.
You have you backslash,
Missing
you open it
backslash.
backslash, but you close it with double quotes.
You back it.
Ah, yeah, I see. Okay, so the backtick string, if you do a double quote string, and you can have backslash whatever stuff in there, like escape stuff. If you do backtick strings, it's just a string literal. Nothing is going to be interpreted in the string or done with it. It's just a literal string.
Can you do multi-line where you backtick and
Yeah.
put variables inside? And things
Yeah.
like-
But you can actually do the same with normal strings. So this is going to be, oh no,
Yep.
not.
In the backticks.
Sorry, cannot. But can you?
Yes.
Yeah, you can. Okay, only backtick strings you can do that. Sorry. And now it's going to be actually quite
Never
useful
quite
for
used it
me
as well.
because my JSON has
Sounds
double
special.
quotes in it,
Yeah.
so I'm just going to use
Okay.
Same thing on
single
backtick.
quotes here.
You can put variable.
Um,
Put variable inside.
if
No, okay,
arrow
that's
You
not
need
so
a template.
easy.
Yeah.
is
This is not like Python where you can do a lot of things.
um,
interpolated strings.
JSON
Okay,
dot
that's the useful part.
Marshall. I'm gonna.
Not by default. You have to
Extreme
use the
byte.
template classes.
Okay.
So I'm just
Packet.
gonna cast the
Packet.
string to the byte array. So actually, before I said like strings are immutable, so you cannot change the contents of a string. If you cast it to a byte array, you can change the contents, not of that string, but of the byte array. So this is always gonna make a copy. And in Go, a lot of stuff actually doesn't work on strings, but works on byte arrays instead, because you can change stuff in them.
You could change things in the middle of a string, isn't it? Not sure. Can't you change things in the middle of a string? I'm not sure. If you assign a
Then
real.
you need to make a copy of it.
Yeah, true, of course. Yeah.
Now I hope I have the order of arguments correct.
Yeah, true.
Okay, I'm gonna make it different. I'm not gonna do 1, 2, 3, 4. I'm gonna say 12, 1, 2, 3. See, I had something wrong. I need to make this. Yeah. Okay, so now we marshaled it to something that's really not that important anymore. I can also take a JSON string that I have. I already made this whole structure here in A. I don't have to, but I can just unmarshal that string into A, back into A, and print it. So now it's going to print, well, this whole thing with instead 13, 12, 13, and 14. So it's really easy. And if I don't have this whole thing, I can just say A is of this type. I'm not going to create all of that. I just know, like, oh, my JSON is of this super weird type. Then I just define a variable of that type, and I'm going to unmarshal into it. Because I want to change the value of A, I cannot pass A itself, because then cannot change the value of A. Instead, I have to pass a pointer to it. So if I do this, it's going to be exactly the same. So now this JSON.unmarshal just gonna fill in this whole thing into that A variable. And if I do like the wrong type or something, it's gonna say like cannot unmarshal array Go value into type A int. So here we actually have an array here, but here it's an integer, so that's not compatible, so it's gonna give an error. So now you can also see what panic does. Panic basically just gives a runtime error, like it quits your program immediately, prints out whatever you give it as argument, and prints out a stack trace, which is when you're writing your code, it's quite useful to just panic. If you're actually writing production code, you will probably have something here to handle the error, but if you're developing stuff, then I usually panic. So you see, Go is strictly typed, so you cannot just do whatever you want with a JSON. You always have to create something that specifically fits in there. So I can also have like a struct which has B, which is an integer, and C, which is a string. Now I'm gonna make it of type A. I'm gonna change my JSON a bit, so now it's gonna be an object with a key B to a key C, which is a string, blah blah. So now I have this JSON, which is an object with a B and a C, and I create exactly the same structure in Go because I know the JSON I'm going to get from someone or from some service or whatever is going to have that format. Now if I run this, A is going to be a structure of type capital A, which contains B is equal to C and a B equal to 2 and C equal to blah blah. If I have extra stuff in my JSON, D, I don't know, something else, it's just going to ignore it because yeah, it can parse this, but I don't have a D in here, so apparently I'm not interested in it. Another thing that's in Go, you have struct tags, which looks like this. So for example, I can assign a JSON tag to this. Blah, blah. So this is actually, in Go, you can actually look at what kind of, if I have A, I can have special packages and stuff that I can look at the type of A and I can see that it has a B struct variable, and then I can read this. So what the JSON package actually internally does is see like, oh, I have a member B, it has some extra information attached to that B, a struct tag. I have JSON in here, so I can also have something like if another package uses struct tags for something else, like blah blah is 2 or 2 whatever.
What we normally do is that we have one encoding for JSON and
Yeah.
another one for XML, for instance.
Yeah, for
So that
some
means
here
is
you
that
can
yeah.
say like XML, it's gonna be a full bar.
Yep.
So what this is gonna do is I have the variable of not the variable, the member called B, but in my JSON I want to call it blah blah. So if I'm gonna run this, now B is gonna be 0 because there was no blah blah in here. Well, there's blah blah. There's no blah blah in here. So now if I do blah blah, it's gonna do, okay, B is 2. So now when it parses, it's gonna say, okay, I have blah blah, a member called blah blah. Oh, here I want to have blah blah in B, so it's gonna do like that. And the same with if I marshal it now. So unmarshalling is putting it back into something. Marshalling is making JSON out of it. If I would marshal this struct, it's also gonna do blah blah instead of B. And I can say like if I use the XML package, because XML is XML.
You can use both at the same time.
Oh,
Yeah.
wait.
You can use both
Unmarshal.
at the same time.
Yeah. So in this
I'm
case
gonna
is that you can
marshal it in
marshal
this
it and
call.
unmarshal. Spelling? Marshal.
Marshal it, I get
You
bytes
probably
back,
need
whatever.
unmarshal then marshal.
Else I'm going to. Now, of course, I have to.
He needs
fill
to
this
yep
with
define it something else. Yep. Yep.
B is 4, C is whatever. Oh, by the way, the trailing comma for the last member is always required.
Oh, okay.
Wait, so it's gonna go
Interesting.
16 bucks. Yeah, okay, so it's gonna complain like unexpected semicolon or new line. So this comma is really required. In JavaScript, a lot of people don't write that comma because EA6, I think, can't
Yep.
understand that.
Yes.
I think it's really good that it requires this comma, because if you have a program like this, and I have it in Git, and I add something to it, then my change in Git is only going to be one line, which is only this line. If I don't do that trailing comma, and I add something, then it's going to be like this, then my change is going to be add a comma to this line and this line. So it's actually always better to do the trailing comma. That's why in JavaScript I always do the trailing comma as well, because your diffs get smaller and more clear. Anyway, if I do this, so now, like I said, I have B here, but I say I want to call it blah blah, so in the JSON that it generates, it's going to be called blah blah. And like XML has its own struct tag as well, so I can actually, I think I can just change this to XML and this to XML, run it, and it's gonna create XML for me instead. And now, because in XML I say I want to call it foobar, it's gonna create a tag called foobar. So you see XML and JSON parsing in Go is super easy and super interchangeable and whatever.
But the catch is we need to define the schema, the struct or whatever.
Yeah,
Yes.
yeah, it's always a statically typed language. One thing you can do, it's a bit ugly, some people do that, you already mentioned it. If I have this JSON,
You is the
I'm gonna say
unmarshal.
var A is of type A, I'm gonna unmarshal again, J again, this, okay, that's, and then this is still better. No, it's not gonna work.
Byte. J equals to byte.
Yeah, byte array.
Yep.
So this is still gonna work. Now it's gonna do yeah. So now it's still gonna unmarshal. Still gonna unmarshal this, but I still need to define this whole struct. What I can also do is, I had interfaces before. I can also use an empty interface, so it doesn't define any methods or whatever, it's just an empty interface. And now when I run it, it's gonna sort of, the JSON package is gonna be sort of smart, and it's gonna say like, oh,